Andrew, not to be a dick, about being a dick, about being a major in the same army. But
this video was sponsored by Brilliant. As
you
I'm
just
sure
got
pretty much
recruited
everyone
after
watching this knows,
certain book
regular
for me.
trig goes hand in hand with the unit
So I wanted
circle,
this to come
which
up.
has an
This is
equation
my
of x
3B,
squared plus y
1B
squared equals
stuff,
1.
talking about math,
Plot a
eater
point,
guy.
cosine
You're in
of theta,
you're in
comma, sine
3B,
theta,
1B's house, and I
that
play
point will
E2 for
guaranteed lie
3B.
somewhere on that circle.
It's like I
Then
will
as
go
we
hard.
sweep the input angle,
It's
that
me and
point
him in the
simply
room. He's
moves
still
around
the
the circle.
warden. I play the
Now,
warden. I go
hyperbolic trig
hard
seems
for it.
completely unrelated at first.
Is Ben Eater.
Hyperbolic
Or
cosine
3B,
involves
1B.
adding two exponential
We have
terms
Zach in here.
and
We'll
dividing
talk
by
about
2.
it. That's a
And
rational
hyperbolic sine
M2
is
matrix
just about
on
the same,
dimensional
but with a minus
analysis.
sign on the numerator.
Hot or cold in fifth
However,
dimensional
this time,
reverse time
hyperbolic trig
analysis
and
of
these
broke down
expressions
scatter
go
patterns.
hand in hand
That's
with
what
a
the shots look
hyperbola
like on
that
the
has the equation x squared
graph.
minus y
No,
squared
I'm gonna
equals
let this
1.
play through. This
But
probably
they go
doesn't make
together
sense to
in
you.
the same
I know
way.
calculus.
If we
I
plot
have a stone mill.
hyperbolic
I have a
cosine,
board
comma,
factory. I have
hyperbolic
a
sine
farm
of
and a
some
cow.
input, which is really just the same as plotting this here with that input of 0.5 in the
And these kinds
exponents.
of tricks are
Then the point
important
will
because
lie on the
when I
hyperbola.
find the hyperbola
And
or
as we
the
change that
Bell's
input,
equality
the
to
point
this
simply
technique,
moves
and
along our curve.
that's some hammer drill
So there's
numbers
one
for
way trig and
AVE's
hyperbolic trig
learning
are actually
curve where
much
the
more
last
related than they first
10%
appear.
is living off
And when
of
we
the
move to
stone
the
mill.
world of calculus, we see something similar. We know for the function
So
y
again,
equals e to
I
the
have in
x,
here
it
the
has
name,
property
the
where
personal
derivative
information
equals
set up,
itself.
a
Nothing changes.
day planner
And
for
of course, e to the x
2022.
satisfies this differential equation.
Okay.
For the
It is
functions
not
sine
November
and
yet.
cosine,
Come
they
Monday,
have the property
my
where
first
the
day back to
second
work,
derivative
Monday on the
equals the
1st,
negative of
I have
the
a
original
roster
function.
list
The
which
second
goes
derivative of
through
sine of x
to
is
December
negative sine
with
of
an
x squared.
overall count
And
chart
these
for me. If I
functions
just wanted to
satisfy
make the
this
3-page
differential
model, I can make it a skipper.
Well, hyperbolic sine
Pencil
and
that in,
cosine are
erase it,
almost
remember the
same, and
days,
just
write
add
the
more to
numbers
this picture.
down.
They both
Use
have the
that
property where the
method.
second
So
derivative
it's one of
is
those
the
ones.
same
I'm
as
just
the
going to
original
choose it for
function.
dimensional
And these
analysis where to
hyperbolic
put the
functions satisfy
the
this
lines and the
differential
bars
equation.
in here for
Now,
what
probably the most famous equation of this form is that
Wednesday
which
the
describes
1st
a mass
and
on
a
spring
blank
with
of
no
what's
friction.
going to go
The
there.
force of the spring
Y
is
E
minus
X
kx,
Wednesday
and that
the
equals
1st
ma, or m
Y
times the second
prime
derivative of position.
equals Y.
The solution to this is a simple sine or cosine
Now
curve
there's a spring.
as the block just
If you
oscillates
forget about
back
that
and
spring
forth
in this
with no
pinball
decay.
machine, it's going to be right in the ball.
And the negative is here because force is opposite of displacement. You try to push the spring
She ain't
in
going to want
and
you,
it will
Gunny.
push back
She's
the
not
other
going to
way.
want you. Not with me in the room.
However, if somehow we had a spring which did the opposite, like when you pulled it to the right, the spring applied
So
the
again,
same
you know, that's
magnitude of
if
force,
that
kx,
that's why that one's
in the
independent. It
same
looks different.
direction,
It will do
and
different
just
things
cause the
to your
block
brain
accelerate to the right forever,
and makes it
then we
different.
model it
So
with
these other
this
ones
equation,
are just
which is
kind
same
of
with a
master
positive
keys.
kx,
Can I use
and
them?
this matches
Yeah.
the differential equation we see
Picasso
here.
over
So
there
the
at the
solution would be a
pawn shop,
hyperbolic
silver and
cosine
gold.
or
I
sine
could come
curve.
by later and
It
drop
wouldn't
this
be
off, and you can
parabolic
pay
like a
whatever you want
constantly
for the mass
accelerating
gap,
rocket,
right? Being
and
a
it wouldn't be
STEM,
purely
millennium
exponential
math
like
problem,
this,
resume,
but it
field
would be
theory book.
close. It would actually approach the exponential curve as an asymptote.
I'm cocky about it too.
Alright, that's not a real application.
Then
but
I got
at least in school,
5
I
days,
learned that,
5
hey,
work
it's called
days, Monday through
hyperbolic trig
Friday,
because it has
the
trig-like
3rd of
properties,
January,
such
because
as
I want to
the derivative of
have
sine is
December.
cosine,
I have
and the
November and
derivative of
December,
hyperbolic
which is
sine
into
is hyperbolic
tomorrow
cosine.
or Monday.
Cool, but hopefully
I'm
you can
ready,
see that there are
cock
more
lock, building
meaningful
into this base
properties
system.
just in
Have the
regards to
7-day count
mathematics
for
of
how many
hyperbolic
pallets you
trig.
just track a fucking
But
rabbit.
now let's get
That's
some real
bang,
applications.
hit the plate.
The most famous example, which I've discussed
The
before,
applications
is
of
the catenary
hyperbolic
curve.
trig.
When
We're
a
just
cable or rope hangs between
you
two fixed
brought me
points,
Zach,
it
and
is only acted
he was
upon by
kicking
gravity.
about
The resulting
hyperbolic
curve is
trig.
not a
You know,
parabola,
we all
but
got
rather
back
a
in the
hyperbolic
office and
cosine
not in front of the
curve.
kids where you
They're
burn the
close,
play.
but not the same.
And we're gonna go, well, did you do
Using
this
the
when I get
calculus of
to
variations,
the?
we find that
Alright,
this
so
is
now you have
actually
a
the
5-week
curve
thing
which
on
minimizes potential
1,
energy across
2,
the cable.
3
You
half
could say this is
pages,
the curve that, quote,
2 and a
hangs
half
the lowest. If you
half
took every
pages
possible curve
out of
between the fixed
188
points that had the
or
same length as the
120
cable,
pages,
and found the potential energy
where
at
the
each
first
point
3
and then
or
integrated
2 and a
across the entire
half
thing,
are
you'll find a
devoted,
hyperbolic
or 1 and a
cosine
half
curve
is devoted. So
minimizes that value.
I want you to think about the X, Y's, and math that
And that's
goes into
exactly
something
what
like that
nature
in
sometimes
time
likes to
dimensional
do.
analysis
Nature sometimes likes to minimize things. In fact, if we
of.
take this problem
Now I'm
up a
giving you a
dimension,
price,
we
man. Now I'm
find
gonna give you the
something
weekly.
similar. If you
Those
take a
days, you
catenary
track
curve,
them, put them
hyperbolic
in one
cosine,
brick
and
matrix.
rotate it about the x-axis
Here's
penetrate
last one for the
surface,
weekly. It looks like
we
the
get
first
something
one. Here's
called
the
a
count
catenoid.
condensed in a half brick instead of the November
This is the
and
shape you get
December
if you take
full
two
chart
rings,
model where it
dip them
gives you
in
room
soap
to
film, and
erase
slowly
stuff and
separate them.
do it differently just because X
So
and
why
Y
do
is
we get
positioned
this
differently.
surface and not like a cylinder?
Fixed
Because again,
crew
sometimes nature
initials
likes to
on
minimize
January
things.
the
And this
22nd for
catenoid
what
does
this
just
price
that.
matrix
In
does.
fact, it's known as a
And to the
minimal
totals
surface.
of those numbers, if you can
Of the
graph them
infinitely
there with a
many surfaces
calculator,
that have these two
or
rings as a boundary,
the
such as
original
this
kind of
or a
price
cylinder, for
matrix, it
example,
might change
this
later. It
catenoid
could be
here is
stretchy
the
or
one with the
poppy
minimum
inside of
surface area.
lumber.
This is what soap films always do. Whatever your wireframe or boundary, that soap film will take the shape of a minimal surface with that
So
given boundary.
after this kind of comes
The
a...
more physical reason
This
for
XY is
this
real important
this
to get.
shape, which
You can
minimizes
find
surface
that.
area,
What you have to
also
go in the
minimizes
boss's
elastic
office, hat in
energy within
hand.
the soap film. So it's really energy that nature likes to minimize, just like we saw with the catenary curve. A link below this great
Or you
video
can
on
figure
minimal
out subtly
surfaces by the Action
over it
Lab,
and do
where you
your own
can see,
models
like,
and
for a
multiplying
cube
it just to
boundary,
come
you get
close.
something
Put
a
a
bit
dollar
more
board in there
complicated than
between
you
you and the
might
cruise.
expect.
Obviously,
You don't just get
that
a flat
cannot
film
be it
surface
in
on
Verdon
all
square
six
law.
faces if
Cannot
that
be
doesn't
that
minimize
number. It'd be
surface area.
impossible. That would
As you can
need to be a
probably
magician,
tell already,
warlord,
minimal
warlock
surfaces
over
are
there.
pretty much always
Probably not.
strange looking,
Probably
and they're
not, based
not
on the
easy
rabbit
to
color.
find.
Probably just regular Murphy
But it's
doing
not just soap
physics. No
films where
offense,
we
being a
encounter
Murphy.
minimal
In a
surfaces,
good way.
as within the field of material
And then the
science,
after action
all
report
the
that
way
comes
to
with
study
that, because
black
as a
holes and general
landscaper around
relativity,
here moving
minimal
stuff around,
surfaces are an important
you're going to want
topic
to
in a
talk
variety
about the
of
secondary
branches
actions
outside
because
of
you're
pure
cleaning, you're
mathematics.
sweeping. Those are
But
the
that's
common
all definitely
operations.
beyond this
Those
video.
could be the same thing as well.
Alright,
If you
now
sweep
moving
in
right
with a
along,
broom,
here's something
but
kind
it's
of random that has to do
a
with
derivative
pursuit
L or
curves.
derivative
Let's
$12,
say you're standing on land,
not worth
and
me
you're
to walk
holding a
over there and
rigid
give
rod
him a
that is
damn bit.
connected
He's
to
a
something in
dragon
the
in this
water,
universe
like, I don't
on
know, maybe
page.
some small canoe, which is directly to your right. And while holding that rod, you start to
Meow,
walk forward.
yeah, so...
What would be the path the canoe takes as you walk?
You know, you get the total count
since this
on,
has to be
well, we made a
mathematically
lot
accurate, I
of
found a program online
14
that
foot
shows
cherries
this
inside
exact
of there.
curve,
That's where a lot
and
of
it
that.
looks
Big
like
numbers
this.
in the total overall matrix of ash and soft maple, hard maple, cherry. Whatever X and Y
This
are.
curve is known as a
EX,
tractrix.
EY. You can start making some
Wikipedia has
XL.
an animation showing it being
There
generated.
XL,
when you are
derivative
both
L,
pushing the
derivative
object
T,
and
derivative
pulling. What we just saw was only half the curve.
So you can quantify that,
I'm
yeah,
not
sure.
gonna go
This whole
through
thing,
much of the
derivative L,
calculus, but
derivative
you
X. But
just
this is
need
kind of
some
like
Calc 1
X
to know how to
squared,
set
and
up the equation
it's beat
that
up,
solves for
it's
this curve.
different. So that's sliding
Here, I'm
camps,
gonna create
right?
the
You got
same
that
thing
one,
in
that
Desmos
8-footer,
where we have the person,
and so
the
you get that
rod,
physics,
constant
it's great.
length, and the boat. And here you can
You
see
get
the boat
that-
move along the tractrix curve
That's
as the person
one-handed
walks.
whip around that you do with it,
But notice at any point on this
and
curve,
then that becomes
this
like
here,
the
tangent
top line
lies
of doing that
directly
kind of
on the
graph.
rod.
Because
Since the rod is pulling
over
in that
time I'd
direction
tell
at that
IH,
moment.
but more
And this will
IQ,
always
well
be
that
the
hurts my
case.
shoulder. If
So
I
the
keep doing it like that, and
dydx
it's
at
not
any
the easiest way
point
based
is gonna
on
be
friction,
equal to the slope
that
of the
straight
rod
line, that
at
slope,
point.
Reso
To
run,
find
I think
this,
that come
we
up
just
in
need to
here.
make a triangle.
Derivative
The
Y over derivative
hypotenuse
X.
is just the length of the
Yeah,
rod.
which is a
so
little
that's a
case
constant.
derivative. It's in
We'll
the
call it L.
secondary order or some bullshit, but it's still the
base we can
first
just call
order. It's
X,
either up
since
or
that
down when
length
you make the
matches
rationalization
per
on
hex
that.
of the boat.
Marshmallow right
And
there.
using the Pythagorean theorem, we find the height
So
is
things
root
about triangles,
L
they're,
squared
they're,
minus X
they're a bit
squared.
easier to...
So the slope at
circle
this
is
point
pi
on the
over
curve
2.
where the boat is,
It's
or any other
2
point,
points of a
is
black
going to
hole
be rise
problem.
over
They give you
run,
neutrino,
root L
neutron,
squared
and
minus X
electron,
squared, all
and
over X.
whatever the the
But
nucleus
it's
is
purely
here
negative
for
in this case,
an
since I'm only
element,
considering the top half of
or
the curve,
because
where
it'd
all
be
the
wave
tangents have a
function.
negative slope.
In a Fermi lab, it would be
But then all we have to do is solve this
inverted wave
differential
function that they
equation, and
programmed
we
to
get
then
the tractrix equation,
2
which is this
phases,
here.
3 phases, not just the 50 cal. They pretty much got that thing.
Now
dancing
hyperbolic
around.
trait
Dance
comes in
monkey dance.
because this first term can easily be written in terms of the inverse of hyperbolic secant. We can also parameterize the equation, and if we do so, both the x and y
So
coordinate
those
as a
can be the
function of
after
time
action reports,
involve
the
regular
side task
hyperbolic
programs.
trait.
How do I want them to learn that's what that
But
action
here's
is,
probably my favorite
and how to
part of this.
capitalize on the value of
Notice
that
if you
thing?
find
Again,
the
go back to the
normal line
cants and
to this
figure out how
curve
much
at a
they're
few
worth
points,
today.
They don't all intersect at the
And
same
inside
location,
your
but they bunch
value
together
for
up
why
here,
you signed certain
and as you add
X's.
more, we see this kind of envelope is created. This is known as the evolute of the tractrix. And
I
that
don't know what you want.
envelope you see
I
in
can't tell
blue
you. Nope,
is
this
the
doesn't fix
catenary
it.
curve,
Doesn't fix yours
hyperbolic
whatsoever.
cosine.
This one's designed for me.
That's kind of cool.
You may
but there's
find
more.
it beneficial.
If you take the
It
catenary
could
curve
be useful
and
to
imagine
you,
a string being
but it wouldn't
wrapped
be as
around
useful to you as
it,
it
the
was
end
with
of
me
that
standing
string
right
will
next to you
trace
going,
out a tractrix curve.
"Yeah."
This is known as the involute of a curve. And when you do the involute